Your 2.1 lesson goes over linear equations. With these, we're going to be looking at solving equations when x is in the denominator. So the whole idea with these is to get x out of the denominator. You have a lot of, example 1a, you're given x over 3 plus 3x over 4 is equal to 2. First thing you want to do, find your least common denominator. So between the 3 and the 4, your least common denominator is 12. You are going to multiply the entire equation by that 12, which means every single fraction or term gets multiplied by the 12. So you're going to have 12 times x over 3 plus 12 times 3x over 4 is equal to 12 times 2. So from here, we're just going to simplify and multiply. The 12 times x over 3, 3 goes into 12 4 times, so that's just 4 times x. The 12 times 3x over 4, the 4 is going to become a 1, the 12 becomes a 3, so that's 3 times 3x. And then the 12 times 2 is 24. So from here, you multiply. The 4x, or the 4 times x, is 4x. The 3 times 3x is 9x. So you combine your like terms, and you're going to have 4x plus 9x is 13x is equal to 24. From here, divide each side by the 13, and you get that x is equal to 24 over 13. For example B, we have x plus 2 over 7 minus 3x over 6 is equal to 1/2. For this one, before you find your least common denominator, you can see that that 3x and that 6 simplify. So I'm going to simplify the 3 to become a 1, the 6 to become a 2. So that gives us x plus 2 over 7 minus just x over 2 is equal to 1/2. From here, our least common denominator is going to be 14 instead of 42, so it's a much smaller number to work with. So we're going to multiply everything by the 14. So every fraction or every part gets multiplied by 14. So we're going to have 14 times x plus 2 over 7. The negative that's in front of the negative x over 2, I'm going to put up with the x and turn it into a plus sign. So that's going to give me a positive 14 times negative x over 2. And then that's equal to 14 times 1/2. From here, we're going to simplify. So 7 goes into 14 twice. So that's going to give you 2 times x plus 2. The 2 goes into 14 7 times, so that's 7 times negative x. And then again, the 2 goes into 14 twice, so that's equal to 2 times 1. We're going to distribute the 2, multiply the 7 with the negative x. That's going to give us 2x plus 4 is equal to negative, or sorry, is not equal to, but 2x plus 4 minus 7x is equal to 2. From here, combine my like terms to give me negative 5x plus 4 is equal to 2. I subtract 4 from both sides. Leaves us with 5x, or negative 5x, is equal to negative 2. And then I divide by my negative 5 to give us x is equal to 2 over 5. Oh yeah, that is 7. That's why this is wrong. Okay, so let's backtrack here. So erase all of this. It'll be 7 times 1. Thank you. So this is 7. So 7 times 1, which would be 7. That then would give us negative 5x plus 4 is equal to 7, which would then subtract the 4 over to get negative 5x is equal to 3. And then we would divide each side by the negative 5 to get that x is negative 3/5. If we look at the next part, we're going to be looking at fractions that have x in the denominator. When you work with fractions where you have an x in the denominator, you have to set your denominator as not equal to 0 and solve for what x can't be. Again, you cannot have 0 in the denominator of a fraction. That means that it's undefined. So we make sure that whatever our answers are not what can give us 0 in the denominator. If you do get an answer that gives you a 0 in the denominator, it's called an extraneous solution. This just means that, yes, it's a solution that you get when you solve it, but it's not a solution that works. So again, those solutions that don't work are called extraneous solutions. You're going to look at equations now that work with x in the denominator. We know that we can't have fractions that have 0 in the denominator. So if that is the case, you need to ensure that whatever the expression or expressions are under the fraction or in the bottom of the fraction, you set not equal to 0 and see what the x can't equal. If you get that as an answer, it's going to be called an extraneous solution. So we're not going to include it as an answer. It's just going to be an extraneous solution. So if we look at our next example, we have 1 over x minus 2 is equal to 3 over x plus 2 minus 6x over x squared minus 4. Now that x squared minus 4 is not factored. You want all of your denominators to be completely factored when you do these. So I'm going to factor that x squared minus 4 to be x minus 2 times x plus 2. So we're just going to rewrite this as 1 over x minus 2 is equal to 3 over x plus 2 minus 6x over x minus 2 times x plus 2. So from here, you want to find your least common denominator. This is the equation you're going to work with. Your least common denominator is going to be including all of your parts. So you have an x plus 2, you have an x plus 2. Those are both parts that you have here. So that's going to be your least common denominator. You can do this one of two ways. Either you can find what x can't equal from here, or you can solve the entire equation, then plug your answer back into the denominator of each fraction, see if you get 0. It's totally up to you. I'd rather do it from here to give me what x can't equal. So if I do that, I'm going to set that x minus 2 not equal to 0, and I'm going to set that x plus 2 not equal to 0. Move your 2 over by adding it. So that gives us x can't equal positive 2. Do the other one by subtracting it. That gives you x can't equal negative 2. So those two numbers, the 2 and the negative 2, are if you get your answer to be those, it's an extraneous solution. So from here, we're going to multiply everything by your least common denominator. So the entire equation gets multiplied by this x minus 2 times x plus 2. That you're going to have x minus 2 times x plus 2 times 1 over x minus 2 is equal to x minus 2 times x plus 2 times 3 over x plus 2. I'm going to turn this 6x into a negative 6x, so I have a positive x minus 2 times x plus 2 times negative 6x over x minus 2 times x plus 2. From here, I'm going to simplify. So from the first fraction all the way to the left, I have an x minus 2 in the denominator and an x minus 2 in my least common denominator. They cancel each other out. So that's just going to give me 1 times x plus 2. For my middle part, I have x plus 2 in the denominator and x plus 2 in my least common denominator. So that's going to give me 3 times x minus 2. Then from the last part all the way to the right, I have an x minus 2 and an x plus 2 both in my denominator and in my least common denominator. So they cancel out, and that gives me 1 times negative 6x. From here, I'm just going to distribute or multiply. So I'm going to have x plus 2 is equal to 3x minus 6 minus 6x left over. I'm going to combine like terms on the right side. So that's going to leave us with x plus 2 is equal to negative 3x minus 6. From here, I'm going to move my 3x over, just though my x's are positive. Plus 2 is equal to negative 6. From here, I subtract 2 from each side to give us 4x is so
Is that what you did on the board right
yeah. So these cancel out, and that leaves you with x is equal to negative 2. If you look back from the very beginning, what we did is we found what x couldn't equal. This is what x can't equal. So this is not a solution. This is called an extraneous solution. So our answer for this one is just no solution. If we look at some practice problems, for number 1, we have 3 over x minus 2 over x minus 3 is equal to negative 12 over x squared minus 9. This x squared minus 9 is x minus 3 times x plus 3. So our least common denominator from all 3 of these fractions is going to be x times x minus 3 times x plus 3, which means if we took parts of these and set them not equal to 0, we would have x is not equal to 0, x minus 3 is not equal to 0, and x plus 3 is not equal to 0. The x minus 3 is not equal to 0 would just tell you that x can't equal positive 3. The x 3 is equal to 0 would just tell you that x can't equal negative 3. So the 0, the 3, and the negative 3 cannot. If we multiply everything by our least common denominator, we're going to have the 3 over x times x minus 3 times x plus 3. So that x is already in our least common denominator. It's going to cancel out, and we're just going to multiply by x minus 3 times x plus 3. The 2 I'm going to make a negative, turn it into addition, and that's going to give me an x to multiply by, as well as an x plus 3. Because I already have the x minus 3 in my least common denominator, I'm going to cancel that out. Then with the negative 12, my x minus 3 and my x plus 3 are in my least common denominator, so I'm going to cancel those out and just multiply that negative 12 by x. So it's whatever's missing from the current denominator that's in your least common denominator that you're multiplying the top by, and then you're canceling out the denominators. So this is going to give us 3 times x minus 3 times x plus 3 minus 2 times x plus 3 is equal to negative 12 times x. With the x minus 3 times x plus 3, we can FOIL that out. It's going to leave us with 3 times x squared minus 9. The negative 2 times x is negative 2x. We're going to multiply that by x plus 3. And then that negative 12 times x is negative 12x. We're going to distribute the 3 in. We're also distributing the negative 2x in. So it's going to give us 3x squared minus 27 minus 2x squared minus 6 is equal to negative 12x. We combine like terms, so that 3x squared minus 2x squared is just x squared minus 6x minus 27 is equal to negative 12x. From here, we move the 12x over by adding it to both sides. So this gives us x squared plus 6x minus 27 is equal to 0. Your factors of negative 27 that add up to be positive 6 are negative 3 and positive 9. So this is going to give us x plus 9 times x minus 3 is equal to 0. We're going to set both of these equal to 0 and solve them. So move your 9 over, subtract it from both sides. We get x is equal to negative 9. Move your 3 over, add it to both sides. you get x is equal to 3. Now, before you say that's my answer and that's my answer, check to see what we said that x can't equal from the very beginning. We said x can't equal 0, x can't equal positive 3, x can't equal negative 3. Are either of the two solutions 0, 3, or negative 3? Yes, the x is equal to 3 is. So that's an extraneous solution. We're not going to include that in our answer. We're just going to give the x is equal to negative 9 for our answer. For number 2, we have 7 over x plus 2 minus 5 over x minus 4 is equal to negative 9 over x squared minus 2x minus 8. That x squared minus 2x minus 8 does factor to give you x plus 2 times x minus 4. So your least common denominator here is the x plus 2 times x minus 4. So we will multiply each of these fractions by whatever is missing from our least common denominator. So before we do that, I want to see what x can't equal. From our least common denominator, we have x plus 2, that can't equal 0, and x minus 4, that can't equal 0. If you move your 2 over, if you move your 4 over, you're going to have that x can't equal negative 2, and x can't equal positive 4. So just keep those in mind when you solve this. So the top of the first fraction, that's 7 over x plus 2. We're going to multiply that 7 by what's not in our denominator, that's in our least common denominator. So that's the x minus 4. Oops. The x plus 2 is already in our least common denominator, so we're going to cancel that out. Then we have a minus 5 over x minus 4. I put that negative up top with the 5, turn it into a positive, so a plus sign. And I multiply that 5 by x plus 2. Cancel out the denominator because the denominator is already in our least common denominator. Then with that negative 9, it's over our least common denominator, so we're just going to multiply that by 1. Cancel out the denominator because it is our least common denominator. So this gives us 7 times x minus 4 minus 5 times x plus 2 is equal to negative 9 times 1. We're going to distribute the 7 and the negative 5 in and multiply the negative 9 with 1. So it's going to give us 7x minus 28 minus 5x minus 10 is equal to negative 9. From here, your 7x and your negative 5x combine to give you 2x. Your negative 28 minus 10 is negative 38, and that's still equal to the negative 9. We're going to bring the 38 over and add it to both sides. So that gives us 2x is equal to 29. Then from there, we divide each side by the 2, and we have that x is equal to 29 over 2. That is not one of those numbers that x is equal, so we can leave that as our answer. For number 3, we have 8 over x plus 9 is equal to negative 7. This negative 7 is like saying negative 7 over 1. So when you have a fraction is equal to a fraction, you're just going to cross multiply and simplify. So you're going to do 8 times 1 is equal to negative 7 times x plus 9. The 8 times 1 is 8. The negative 7 gets distributed in, so that's negative 7x minus 63. I want to move my 63 over, so I'm going to add it to both sides. This is going to give us 71 is equal to negative 7x. From there, we divide each side by the negative 7, and this gives us that x is equal to negative 71 over 7. Before we say that's our answer, if we check it and plug it into our denominator with the x, that's going to be negative 71 over 7 plus 9. That does not give us 0 in the denominator, so that is our solution. So you can do it that way also. Instead of trying to find from the very beginning what x can't equal, you can always take your answer and just plug it in at the very end. If it doesn't work, or if it gives you 0 in the denominator, that's when you know it's an extraneous solution. For number 4, we have x minus 5 over x minus 9 plus x plus 3 over x minus 3 is equal to negative 4x squared over x squared minus 12x plus 27. Your answer's denominator factors to be x minus, for this question, we have x minus 5 over x minus 9 plus x plus 3 over x minus 3 is equal to negative 4x squared over x squared minus 12x plus 27. For this one, we were going to factor the x squared minus 12x minus 27 first, so that's going to be x minus 3 times x minus 9. From here, we are going to find our least common denominator, which in this case is x minus 9 times x minus 3. That means that x can't equal 9 and x can't equal negative 3. So we are going to multiply whatever's in our least common denominator that's not in our denominator that we're working with within that fraction with each of these. So multiply everything by your least common denominator. Your denominator of each fraction should cancel out. So with the first, that x minus 5 over x minus 9, the x minus 9 is part of our least common denominator. So we are just going to multiply the x minus 5 by x minus 3. For the next fraction, you have x plus 3 over x minus 3. X minus 3 is part of the least common denominator, so we cancel that out. Multiply the x plus 3 by x minus 9. Then with the last fraction, our least common denominator is the denominator, so we're going to cancel that out and multiply the top by just 1. So that means we are going to have x minus 5 times x minus 3 plus x plus 3 times x minus 9 is equal to negative 4x squared times 1. We're going to FOIL out everything that we have here. So x times x is x squared. X times negative 3 is negative 3x. Negative 5x is going to add with that to give us negative 8x. And then negative 5 times negative 3 is a positive 15. Then FOIL out the x plus 3 times x minus 9. That gives us x squared minus 6x minus 27. And that's all equal to negative 4x squared. We're going to combine our like terms on the left side. So x squared plus x squared is 2x squared. The negative 8x minus 6x is negative 14x. And then that 15 minus 27 is negative 12. And again, that's still equal to the negative 4x squared. So we are going to move that 4x squared over by adding it to both sides. That gives us 6x squared minus 14x minus 12 is equal to 0. We have a greatest common factor within all three of these terms, so we're going to factor out a 2 first. That's going to give us 2 times 3x squared minus 7x minus 6 is equal to 0. Your 3 times negative 6 is negative 18. The factors of negative 18 that add to be negative 7 are 2 and negative 9. So it's going to give us 2 times 3x squared minus 9 times, plus 2x minus 6 is equal to 0. Remember, there's brackets around all of this, so and we're factoring by grouping. So we're going to factor out a 3x from this. This is going to be 9x. We're going to factor out a 2 from this. So this is going to give us 2 times 3x times x minus 3 plus 2 times x minus 3 is equal to 0. Our two parentheses are identical, so that's going to give us 2 times x minus 3 times 3x plus 2 is equal to 0. We're going to set each part equal to 0 and solve. So 2 is equal to 0, x minus 3 is equal to 0, and 3x plus 2 is equal to 0. The 2 is equal to 0. It's a false statement. Cross it out. Don't work with it. The x minus 3 is equal to 0. You're going to add the 3 over to get x is equal to positive 3. The 3x plus 2 is equal to 0. Subtract your 2 over, and you have 3x is equal to negative 2. Then divide the 3 on each side to get that x is negative 2/3. Check back at what we said your x's can't equal. We said that x can't equal 9 and x can't equal negative 3. So this x is equal to 3. Sorry, this should be positive 3, positive 9. X equals to 3 is an extraneous solution. So we cross that out. We don't work with it. But the x is equal to negative 2/3 is an answer. From here, we're going to look at number 5, which we have x over x minus 2 plus 1 over x plus 2 is equal to 8 over x squared minus 4. That x squared minus 4 is factorable. It factors to be x minus 2 times x plus 2. From here, we find our least common denominator, which is x minus 2 times x plus 2. This means that x can't equal negative 2, and it can't equal positive 2. So we're going to multiply everything by our least common denominator. The x over x minus 2 times the least common denominator. The x minus 2 is in that, so the only thing we're multiplying x by is x plus 2. The 1 over x plus 2 is in our least common denominator, so the 1 we multiply by x minus 2. The 8 is over our least common denominator, so we're going to cancel that out and just multiply the 8 by 1. So that's going to give us x times x plus 2 plus 1 times x minus 2 is equal to 8 times 1. So we simplify this, we have x squared plus 2x plus x minus 2 is equal to 8. We're going to combine like terms on the left side. We have x squared, the 2x plus x is 3x, minus 2 is equal to 8. From here, we're going to move the 8 over by subtracting it from both sides. We get x squared plus 3x minus 10 is equal to 8, or equal to 0. Your factors of negative 10 that add to be 3 are negative 2 and positive 5. So that's x minus 2 times x plus 5 is equal to 0. We set these both equal to 0 and we solve. The 2 we're going to move over by adding it to both sides. We get x is equal to 2. The 5 we move over by subtracting it from both sides. We get x is equal to negative 5. The x is equal to 2 is one of those solutions that's an extraneous solution. So we're going to cross it out, and the x is equal to negative 5 is our only solution from here. For number 6, we have 3 over x plus 6 is equal to x over 9. For this one, since the x plus 6 is the only variable term expression in our denominator, we can set that not equal to 0 and solve for what x can't equal. And we're going to get that x can't equal negative 6. So with this one, since it's a fraction is equal to a fraction, we cross multiply. This is going to give you 3 times 9 is equal to x times x plus 6. The 3 times 9 is 27. The x times x is x squared, and the x times 6 is 6x. Because we have the x squared, we're going to move the 27 over by subtracting it from both sides. We get x squared plus 6x minus 27 is equal to 0. Your factors of negative 27 that add up to positive 6 are negative 3 and positive 9. So that's x minus 3 times x plus 9 is equal to 0. We set both of these equal to 0 and we solve. We move the 3 over by adding it to both sides. We get that x is equal to 3. We move the 9 over by subtracting it from both sides. We get x is equal to negative 9. So we have 3 and negative 9 that are solutions to this one. And they both are solutions since neither one of them is the negative 6.